Hi everyone. In this exercise class, we are going to talk about the principal and agent in conflict. But in the outline, we are going to see some extensions of this conflict, which is discussed in the lecture. We are going to consider it with borrowing constraint, where the fixed salary is equal to 0. In the second step, we are going to consider unemployment insurance in the equations. For the borrowing constraint, where the fixed salary is 0, we are going to start with the principle anticipating the agent behavior, as it was also discussed in the lecture. So we have learned that the agent's profit was given as the function, that is S times rho times E plus fixed salary, this is F, minus the cost, which is given in terms of the effort level. So the necessary condition to get the profit maximization in this function was taking the derivative. So with respect to the E, the effort level, which is also the hours worked by the agent, is given by the S times rho minus E, which should be equal to 0. So when we equalize this, we have ended up with E equals to S times rho. So effort level is equal to the share that the agent was earning in respect to the work he is doing times rho, which is the marginal productivity in the participation condition. So considering these two, we know that the agent signs the contract when the profit of it is equal to or greater than 0. If it is not, then he is not going to sign the contract and not work for the company. So when we just think that the fixed salary is equal to 0 now, and consider the participation condition by inserting the 0 into fixed salary, the F, and consider that E was equal to S times rho in the previous slide, the profit of the agent is seen as 1 over 2 times S squared times rho squared. So this is greater than or equal to 0. In this case, the shares, the S is greater or equal to 0, which is the participation condition. So this is also always fulfilled, as we know that the share is among 0 and 1. So in the next step, the principle deriving the value of the variable component, principle considers its own profits in here. So the function, which is also learned in the lecture, is given with this way, this 1 minus S times E times rho minus F, the fixed salary that the principal was paying to the agent to work for his company, and the left-hand side, which was a variable component, 1 minus S times E times rho. So when we're considering the variable component, since S shares is changing depending on the anticipation of the agent behavior, we say that this part is actually the variable component. So we knew that E equals S times rho, and fixed salary was given as 0 because it's in the borrowing constraint. So the profit function now equals to the S times rho square minus S squared times rho square, because we have now gave the values which is now given in this slide. So the necessary condition for the profit maximization is again taking derivative. But now, because we are dealing with the variable component, the principle derives the value of the variable component, and we know that share could actually change, and it is the variable side. The principle is now taking derivative with respect to s. When we take this function's derivative with respect to s, we know that, and we can see that r rho square minus 2 times s times rho square is equal to 0. So in this case, we could see that s is equal to 1 over 2. So the variable component will be set to 50% in here. So to talk about the characteristics of the equilibrium, we could give some examples with numerical values. And if we say that rho is equal to 10 and S is equal to 0.5, we could see that the effort level, which was also given and we know S times rho, becomes 5. So this is the hours that the agent could actually work for the company. And the revenue, which is given E times rho, could be found by multiplying the 5 with 10, so which is at the end is 50. The profit function of the agent and the principal were also given by the functions that we have also solved in the previous slide and found the maximization. And in this profit function of the agent, we could see that S times rho times E plus F minus 1 over 2 times E square is found with the values which is given in the slide 12.5. So the profit function of the principal is also depending on the variable component, the fixed component. So the variable component, as we have seen, it depends on the shares that it is given to the agent because the rest of them stays with the principal and minus the fixed salary that is paying to the agent. So depending on the values which is given, we could find that the profit of the principal becomes 25. So in this case, with these values, we could see that the profit of the principal is greater than the profit of the agent. So when we now consider the unemployment insurance as a second step of understanding the impact of new variables into this conflict, we are going to introduce the unemployment insurance as epsilon. Let's say that agent now does not consider that there is no any salary, like there is no such zero out there, but there is an opportunity to get an unemployment insurance, and we name it as epsilon. And in this example, the epsilon is given as 10. So in this case, the participation condition that we always thought of becomes that the pi a it should be greater or equal to epsilon for this agent to decide to work for this company or not. It was the case where the participation condition was depending on the profits being equal to or greater than zero. But since there is now an unemployment insurance that agent could think of, that should be the profit that he is going to gain by working with this company should be equal to or greater than this value. So otherwise, agent prefers not to work since the participation condition will be affected. So we knew that in the previous slides that the profit of the agent were given with this function, and necessary condition for the profit maximization was taking the derivative of this function. So when we just took the derivative out of this function and equalize it to 0, we have found that S times rho is equal to E in the participation condition. So, but now we are considering that the agent could only sign the contract when the profit of agent, the pi a, is greater or equal to epsilon. So, because we have found that S times rho is equal to 0, and now we know that condition of profits being equal to or greater than epsilon, now we could go on and just consider this function. So in this profit function, we are just inserting E times S times rho, and we are considering this equation by equalizing it to epsilon instead of 0 now. So as it could be seen when we just insert these values that we have found, we could see that now the fixed salary depends also on the epsilon's value. So the fixed salary is given by epsilon minus 1 over 2 times S squared times rho squared. So the fixed component of the content, which is the fixed salary, is negative as long as epsilon does not exceed a certain level. So yes, depending on the value of the right-hand side, that's 1 over 2 times S squared times rho squared's value, then it could be positive or negative. So the agent has to bring money to work if it is negative, because the fixed salary actually which is paid by the principal to the agent becomes negative. As we are now considering that principal is determining the value of the variable component, and as we said, the variable component depends on the shares that is left for the principal. And we know that the E was given by S times rho, and F was found as epsilon minus 1 over 2 times S squared times rho squared in the previous slide. We could now insert these values into the principal's profit, and then we could find that the profit is given by S times rho squared minus S squared times rho squared minus epsilon plus 1 over 2 times S squared times rho squared. So as it is always the case, to get the profit maximization out of this function, we should take the derivative with respect to S, because we are talking about the variable component, and the variable component depends on S, the shares. So now the necessary condition just allows us to find this function. The rho square minus 2 times S times rho square plus S times rho square is equal to 0. When we solve this equation, then we find that S is equal to 1. So the variable component will be set to 100% in this case. So the variable compensation component thus includes the entire return. At the factory gate, the agent pays the fixed component F to the principal and may then do what he wants in the company and reap all the fruits he sows himself. So that is, the F could be negative, although we say that the agent should pay to get the job at first stage because it is seen as negative. But as we see that as the shares becomes 1, which is the shares that agent actually gains after the work is done, we could see that agent could get actually profitable out of this work. So the characteristics of the equilibrium says that given E equals to S times rho and S is equal to 1, the basic scenario condition E equals to rho is satisfied. So it is actually the same case when we consider the first stages, the first cases that we saw in the lecture. So the agent would work just as much as the principal if he runs the business alone. So if you again consider these two functions, the fixed salary function, the 10th, and the 11th, in which the agent profit is given, we are now inserting the 10 into 11. So we are now inserting F into the agent's profit, and we get that the agent's profit is equal to epsilon. The profit is larger by epsilon than the profit in the reference solution. So it was dictated by the participation condition, as we said that the profit should be greater or equal to epsilon. The principal considers the agent's behavior in this case, so the minimum amount that actually agent wants to work for the company will be equal to epsilon. So this is actually satisfied. In the numerical examples, if we just put some values and understand uh, the uh, the fixed salaries values and the profits out of them, we could say like S is equals to 1 as we have found, and if we say rho is equal to 10 and E is equal to 10 and also the epsilon is equal to 10, and if we just insert all of these numbers into the functions that we have shown in the previous slide, then we end up with the values of minus 40 for the fixed salary and 10 for the profit of the agent. So the agent produces 100 units of the products, and he has to pay the fixed component of minus 40 to the principal. Yes, we see that the minus 40 in here, as we have also said that epsilon, if epsilon does not exceed a certain level, the fixed salary seems to be minus. So yes, the fixed salary is minus in here, but the production seems to be positive, which is given by 100. And the production is the revenue actually is given by R, and that was E times rho. So in this case, E is 10 times rho. 10 is 100. So this is the amount of units that agent produces. When we look at the profit, we see that it becomes 10. So it is exactly equal to the epsilon, which is given as 10. And this also satisfies the condition that we have found, which is pi a equals to epsilon. So we are given E equals to rho as S was 1, and we know that F is equal to minus 1 over 2 times rho squared plus epsilon, since S was again 1, and we are just saying only times rho squared. The profit of the principal is given by this function. So in this function, we see that when we just give S 1 again, we see 1 minus 1 times rho. E was equal to rho as it is seen on the slide. So we can see that the variable component is actually 0 in here. The variable component of the profit of the principal is 0. But the fixed component is not in this way, so it is not 0. If we just put the values of rho equals to E and epsilon is equal to 10 as it was given in the previous slide, we could find that the profit of the principal becomes 40. The principal does not earn any variable income because it is 100% paid to the agent as it is seen in here, as the shares is always 100% in this case. Principal receives his profit completely from the fixed component he receives as an entry fee from the agent. Yes, as it is seen in this case, the left-hand side of the right-hand side of the equation, which is the variable component, is 0, but the fixed salary, which was given as minus 40 for the agent, becomes plus 40 for the principal, and it is written as the profit for the principal at the end. So if rho is greater than square root of 2 times epsilon, the principal's profit is positive. So another thing that we could consider for these equations will be the reference points. The reference solutions will give us some explanations for each of the case. So in this first one, the profit of the agent with unemployment insurance is equal to epsilon, we said, and it should be greater, it is greater than the reference point of agents, and it is equal to 0. So in this case, the profit of the principal is given with this 1 over 2 times s squared times rho squared minus epsilon, and it is less than the reference point of pi. And if it is the case, and it is the case, then we say that 1 over 2 times s squared times rho squared. And when we look at the F, the fixed salary with unemployment insurance, then we have seen that the equation was minus 1 over 2 times s squared times rho squared plus epsilon, and it was greater than the reference point of F. So when we consider these reference points, then the equation seems to be minus 1 over 2 times s squared times rho squared. The fixed compensation greater than that of the reference model in this case. If the agent's effort level is less than square root of 2 times epsilon, the principal will have a negative profit and thus no incentive to participate, as we have discussed it in the previous slide. In other words, when unemployment insurance is high, principal prefers to work himself rather than employ the agent. Yes, when the unemployment insurance is too high, then agent would really prefer to get high profits to work for this company, or else he will not choose to work for this company since the unemployment insurance really satisfies him. So this was the end of the exercise class. Thanks for the listening.